Okay, today I would like to talk about the limit laws. So at this time, I would like you to pause this video and write the limit laws down. Okay, I assume you have written the limit laws down, so I'm just going to briefly talk about each one. The first one handles the limit of the addition of two functions, and it can be described as the limit of each function being added together. So I can take the limit of the sum of two functions or the sum of each limit. And that also applies to subtraction, multiplication with a constant number 3, number 4, multiplication between two functions, and the division of two functions can be redefined from one limit to two limits. Make sure you're paying attention to how that's happening. Okay, so let's actually look at an example of doing this. So we're going to come down here, and what I like to do is, first of all, take this very first one, get pen going here, and I'm going to start by rewriting it as the limit of two functions being added together. So it's the limit as x approaches -2 of f of x plus the limit as x approaches -2 of g of x. Now, I can come to this graph and see if these two limits actually exist. So here's where x is -2. Let me get my pen, it's a little tricky sometimes. Here's where x is -2. And I'm going to look at f of x and see what is the function approaching, if anything. And what the function is approaching is 1. So the limit of f of x as x approaches -2 is 1. And now I'm going to go to g of x and again see what it is approaching, and it appears to be approaching -1, which means I can add these two together to get my answer. The limit of f of x as x approaches -2 plus the limit of g of x as x approaches -2 is 1 plus -1, or 0. So that's my first. And I'm going to go through each one of these and rewrite them same way. So now working on the second one, I'm going to say this is the limit as x approaches 3 of f of x minus, this is limit law 2 combined with limit law 3. So I can rewrite the the subtraction as two limits and bring out the multiplication on the outside. Oops. So I have the 2 times the limit of g of x as x approaches 3. So I'm going to come over here and I'm going to look at my graph and see where x is at 3. So we've got 1, 2, 3. I'm going to look at my two functions. F of x in this situation, oops, sorry, my screen's a little bit sensitive sometimes. Oh, now there it goes too far. Okay, so let's see, the limit of f of x. Here's f of x, and it's approaching 0 as x approaches 3. Minus 2 times the limit of g of x as x approaches 3. So here's g of x, 1, 2, and it's approaching the value 1. So now I can take that 0 minus 2 times 1 to get my final answer, which is -2. Third one. Let me scroll over here. Okay, and let me start by rewriting it. First of all, this is the limit as x approaches 1 of f of x times the limit of g of x as x approaches 1. So now I'm going to go over here and take a look at what's happening around 1. So here we go. X is 1 is right here. F of x is 2. G of x, well, let's take a look at g of x. As I approach 1, From the left, I'm going to -2. As I approach 1 from the right, I am approaching -1. I am not approaching the same value, which means the limit of g of x as x approaches 1 does not exist, which means the product of these two limits does not exist. So even though I was able to rewrite it and attempt to evaluate it, you have to recognize whether the actual function exists or not that you're trying to evaluate. And last but not least, let's take a look at, let me rewrite it. The limit of g of x as x approaches 3. Oops, yeah, I actually didn't want to do that. Okay. Divided by the limit of f of x as x approaches 3. So that's going to equal, let's see what the top is. Make this smaller now so I can see everything. There we go. So the limit of g of x as x approaches 3. Okay, let's take a look down. G of x, we were there before, and here it is. G of x as x approaches 3. 1, 2, 3. G of x is approaching 1. As I look at f of x as x approaches 3, here's f of x. F of x approaches 0. So the limits both exist. However, let's just back up, and this is always an important part with division, if your denominator does not equal 0, because dividing by 0 in general is not defined. So this does not exist. Even though both individual limits existed, 1 and 0, because we were dividing by 0, this particular setup does not produce an answer.